Hello, welcome to homework questions 58 through 63 in Chapter 3. Question 58. Examine the rectangles formed with tiles below. For each figure, write its area as a product of the width and length and as a sum of its parts. So we know that each of these tiles represent x. We have our unit tiles, we have another x, and then x squared. So the length of the length and the width of the rectangle, this would be x plus 3, and then x plus 1. So the product is x plus 1 times x plus 3, and that's equal to the sum of its parts, which we have 1x squared tile, 4x tiles, and 3 unit tiles. For part B, once again, we can label the x tiles, the unit tiles, and then this one we have 2x squared tiles. So the length and width would be x plus 2, and then we have 2 x's, so that's 2x plus 1. So the product is 2x plus 1 times x plus 2, and that's equal to the area of its sum, or the sum of its parts. There's 2x squared tiles, there are 5x tiles, and then 2 1 tiles. So once again on these problems you're writing the area as a product, which is length times width, and then the sum of its parts, which is just adding up all the tiles. Question 59. Find the total area of each rectangle below. Each number inside the rectangle represents the area of that smaller rectangle, while each number along the side represents the length of that portion of the side. So 4 times 11 would be 44. 4 times 3 would give us the area of 12, or 12 divided by 4. We have 39, so 3 times what gives us 39, or 39 divided by 3 is 13. And then for this one you have 11 times 13, 143. So now we have the area for the 4 rectangles that make up the bigger one. So we're going to take each of these areas and add them up. And when we add up all the areas, or the sum of its area, we get 238 square units, or units squared. On part B, 8 times 5 is 40. 5 times 6 would give us the area of that rectangle, which would be 30. 6 times 3 is 18, or 18 divided by 6 is 3. And 3 times 8 is 24. So once again, if we add the area of each of the individual rectangles, it will give us the area of the larger rectangle. And so this area would represent 112 units squared. Question 60. Solve each equation below for x and then check your solutions. So on part A, I'm going to multiply both sides by 8. By doing that, the 8 in the denominator will cancel and give me x equals 8 times 3/4 is equal to 24 over 4, which simplifies to x equals 6. And then if I plug that in to check, 6 divided by 8 is equal to 3/4. So if we reduce 6 over 8 by a factor of 2, that would be 3/4. So 3/4 is equal to 3/4. On part B, I'm going to multiply both sides by 40. So that'll be 2 over 5 times 40 is equal to x over 40 times 40. Now on this side it just cancels, so it just gives you x. On this one you would get 80 divided by 5, and that is 16. So x is equal to 16. And once again, to check that, that's 2/5 is equal to 16 over 40. And if we reduce 16 over 40 by a factor of 8, that would be 2/5. So it does check again. Alright, on part C, 8 and 12, if you multiply by 12, it's not going to cancel the 8. So what number do both of those go into that we could use? And that potentially could be 24. 8 and 12 are both multiples of 24, so this would be 1/8 times 24 over 1 is equal to x over 12 times 24 over 1. So 24 over 8 is 3, and then 24 divided by 12 is 2. And then divide both sides by 2, and we get x equals 3/2 or 1.5. And once again, to check that, we just plug it back in. 1/8 is equal to 1.5 divided by 12. We could simplify that. We could divide it and check the decimal form. What I could do to simplify this is multiply both sides by 10. That gives me 15 over 120. And then if I reduce 15 over 120 by 15, 15 goes into 128 times. So 1/8 is equal to 1/8. So it does check again. On part D, I'm going to do this one just a little different so you can kind of see a different way to do this. 10 and 15, instead of trying to figure out what number they both go into evenly, we can do them as two different parts. I'll first multiply by the smaller number of 10, not that it really matters. So this will be 10 times x over 10, and what that's going to do is cancel the left side, but it won't cancel the 15, so we'll have to do another step. So this gives us x is equal to, well, I guess in this case it doesn't matter because we already have x by itself, but that'll be 120 over 15, and then when you take 120 and divide by 15, you get x equals 8. And so to check that, we can plug that back into the original. 8 divided by 10 is equal to 12/15. Reduce the left by 2 and reduce the right by 3. And we get 4/5 is equal to 4/5. And so really on part C, I guess instead of multiplying by 24, since x was divided by 12, I could have easily multiplied both sides by 12 and I would have had x by itself. But either way, works out, once again, different ways to solve each of these problems. Question 61, Mailboxes Plus sends a package overnight for $5 plus 25 cents per ounce. United Packages charges $2 plus 35 cents per ounce. Mr. Molinari noticed that his package would cost the same to mail using either service. How much does his package weigh? Alright, let's think about this. Mailbox Plus, it's going to cost, we'll just use C as cost, $5 plus 25 cents per ounce. Instead of using, I'm not going to use an O for ounce, I'll just use W for weight. Alright, and then we have the United Packages. It's going to cost $2 plus 35 cents per ounce. And so we want to know when the cost is going to be the same to mail those. So if we know that the cost, or the C, is going to be the same, we can just say, okay, well, at what value of the ounces or the weight would make sure that the cost is the same. And so we'll just set them equal to each other and solve. If we subtract 0.25W to both sides, and then we can just subtract the 2 over here. So that's 3 is equal to 0.10W or 0.1W. Divide by 0.1 to solve for W. And W is equal to 30, or 30 ounces. So how much does this package weigh? The package is going to weigh 30 ounces. And that means that that's when the cost will be the same for Mailboxes Plus and United Packages, when the package itself weighs 30 ounces. Question 62, what is the equation of the line that has a y-intercept of 0, -3 and passes through the point -9, -9? So we need to find the slope. We're given the y-intercept, which is important because that's one of the two things that we need, but we also need the slope. So we're going to do the change of y over the change of x, -9 minus -3, and then this is your x, -9 minus 0. So that's -6 over -9, and reduces to 2/3. So we have the slope and we have the y-intercept. Y is equal to 2/3 x minus 3. Question 63. Evaluate each rational expression. For each of these, once again, in terms of what we do with rational expressions, if we ever really need to add, subtract, multiply, or divide, most of the time we can just plug these into our calculators. So I'm just going to give you the answers, and then if you want to go through and calculate them by hand or, using a calculator, you can check your answers. The first one would be negative 15 and 1/2. And they're both negative, so you could actually add the 7 and the 7 and get 14, and then you'd have to add the fractions. And it would be more than 1, so that's why we get a negative 15 on that one. On part B, we get negative 5 and 1/4. And this one we're subtracting, but when you subtract a negative, that's the same thing as adding. On part C, you would want to change the 2 3/7 to an improper fraction. So that'd be 14, 15, 16, 17 over 7. Negative. Negative times negative is a positive. And that will give you 17 when you multiply. And then remember on D, when you divide by 1/5, that's the same thing as multiplying by the reciprocal. So it'd be negative 17/8 times 5 over 1. And that is negative 10 and 5/8. So once again, you can do those, by hand or plug them into the calculator. Just make sure in terms of plugging things into the calculator that you are plugging improper fractions in. If you are plugging in mixed numbers, make sure you are plugging those in correctly into your specific calculator.